So now that we've learned our double angle identities, you're also going to get some proofs that have double angle identities in them. Anytime that you have a proof with a double angle identity, you're going to want to use your double angle identity and change it so that you get rid of your double angles. So if we look in here in the first one, we've got a double angle of 2 theta there and a double angle of 2 theta there. We're going to want to get rid of those. If we look here, we've got a double angle of 2 theta there. So our strategy for proofs will be, can we substitute those out to get rid of our double angles? So in our first one, again, remember, we set up our proofs by rewriting the question. Drawing a line so that we separate our left side and our right side. And then go about changing things. Now, when I change a double angle, remember that for the cos 2 theta, we had 3 formulas. For the sine 2 theta, we had 1 formula. So for the sine 2 theta, that one's going to be easy to change first. Our only option is 2 sine theta cos theta. For our cos 2 theta, we have 3 options. And again, all 3 will work, but there will always be one that's the fastest. And that is going to be your job to do a little bit of thinking and say, of those 3, should I use cos squared minus sine squared, 1 minus 2 sine squared, or 2 cos squared minus 1? Which of the 3 should I put in here to substitute that out? Now, part of knowing which one is a little bit of that awareness. What do we have on the left side? What do we have on the right side? What are some of the differences in our fractions and in our work? Well, one difference I want you to notice is that we have a +1 on the right-hand side. And we don't have any adding of numbers on the other side whatsoever. So one of the things I'm going to want to get rid of is that +1. So when looking at my 3 formulas, looking at that last one, and I say, hey, if I use the last one, 2 cos squared theta minus 1, well, then that -1 and the +1, they're going to cancel each other out. And sure enough, when I write the next step, on the top, I'm just left with 2 cos squared theta. On the bottom, I have 2 cos theta sine theta, or sine theta cos theta, it doesn't matter. But I'll be consistent. What can we do? Well, our 2's are going to simplify. And one of the coses on the top is going to simplify with the cos on the bottom. And I'm just left with cos theta over sine theta. How close are we? Well, we didn't change our left side yet, but we can change cotangent 2 cos theta over sine theta, and now that they're identical, we can say our left side is equal to our right side, and say we're done our proof. So we have double angle formulas in our identity. We want to get rid of them. Okay? I'm going to get you to try the second one. With cosecant 2 theta, the first thing you're going to do is change that to 1 over sine 2 theta, because we don't have any double angle formulas for cosecant or secant, but we can change them to sine and cos. So I'm going to get you to try B, and then once you've done B, 10 and 11 and 17 are some more to practice.